Hi, I'm Lauren Brown, and this is my one-dimensional motion video test. This is going to be a video of an object that has a uniform acceleration in one dimension. So let's start off by going over to video physics, where I have my dot diagram set up, and we're going to first watch a video of me dropping the ping pong ball. As you can see, I didn't record the position of the ball after it hit the ground the first time, so I'll only be analyzing it for when I dropped it. For my origin and scale, if I go back to where I scaled it, there you go. I used a 12-inch ruler as my scale, which I put into the scale as 0.31 meters, and I put my origin at the ping pong ball before it dropped out of my hand, with the ball going in the negative direction on the y-axis. Going back to the dot diagram, as the ping pong ball left my hand, the displacement increased between each position, which shows a change in velocity as the ping pong ball falls. Since there is a change in velocity, we know that there is an acceleration. We just cannot confirm if it's uniform or not until we go to the graphs, which I already exported. So let's head on over to the graphs. We are in the y component because I used free fall to show the acceleration. So on the position versus time graph, as I move my pointer around, you can see that the position is changing, which shows a change in velocity. And if I were to get the slope of this, which the slope is what shows the velocity would show up as negative because of where I put my origin, when in reality it is actually positive. Since I put the origin with the ball going in the negative direction down, the velocity shows up as negative, but it is actually positive because the displacement of the ping pong ball was actually getting larger. In the velocity versus time graph, we know that the acceleration will always be negative, so we know we'll have a negative acceleration. And I chose to highlight this section of my graph because it was the most linear of the whole one. And I found out that the acceleration of the ping pong ball was negative 9.371 meters per second each second, which in terms of velocity means that the velocity was increasing by negative 9.371 meters per second every second that the ping pong ball was moving. It doesn't matter if the ping pong ball were to be moving in the positive or negative direction, it would always increase by the same amount. And my data is fairly linear, except for the ending. I'm not really sure what happened there, but we can conclude that this has a uniform acceleration. Thank you.